Goodness.
I think
we're going to get to that point if you can't shut up when I tell you. Okay. So this entire unit and the next unit, we are looking at what we call quadratics. Okay. So you should have been introduced to quadratics in Math 1.
I told him my teacher was
Nope.
retarded.
Hey, listen.
No, but
Be nice. Okay. So if you open this all up, this is a picture of a quadratic. Does this look familiar?
Yeah.
Sweet. Okay, this is called a parabola. The shape of a quadratic. Okay, a parabola is the shape of a quadratic. Tomorrow we're going to look at what it looks like as an equation. Okay. But today we're just going to look at the pictures. Okay. So you can have an upward facing parabola or a downward facing parabola. So I can also flip this and make it go like this. Okay. So take a look at my parabola. Yes, ma'am.
It can never be sideways.
It can never be sideways. No. It's either up or it's down.
Oh, I got something else.
Yes.
You can have maximum and minimum.
We're going to talk about that too. Okay. Max and minimum. Yes, we are going to talk about that as well. What else do we know about quadratics?
It has a vertex.
It has a vertex. Okay. It has a vertex. What's the vertex? Can you find the vertex on this?
The lowest point.
The lowest point. Okay. Listen, your vertex is your lowest point or your highest point. Okay. They also call it your turning point. Okay. So your vertex on this graph is right here. This is your vertex. Okay. I have a low point on this graph. So, Tehran brought up the point of minimum. Because your vertex is a low point on this graph, we call this your minimum. Okay. So, if you look at this little dinky graph I drew up here, I still have a vertex here. But now this is called a maximum. Okay. This is now called a maximum. All right. Which one of these tabs are vertex? All right. So we just covered the tab on the left. In the middle. Okay. So let's fill this in with a definition. Lowest point which we said was a min, or highest point, which is a max. They also call this your turning point. Oops, that's not what I meant. Oops. Okay, they also call this your turning point. What I mean by that is, remember, we read graphs from left to right just like you would read a book. So if I'm reading my graph starting at the left point, my graph's going down, 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 which means it's doing what? Decreasing. Okay. So it's decreasing up to this point of -2. So it decreases until x equals -2. -2, my graph then starts going up. So now it's increasing. So that's why that's called your turning point. So it decreases from -infinity up to -2 because it's going to come down, 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 down. And then at -2, it's going to switch and it's going to start going up, 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 up to positive infinity. Okay.
Why would you say x -2 instead of y -8?
Because you read the graph from left to right, which axis goes from left to right. That's why it's going to be x is -2. Okay. Questions on vertex? All right. Do you know any of these other vocabulary words on these flaps?
Range, yeah.
Range.
Domain, range.
The x symmetry and y. I know all of them.
You know all of them?
I didn't know yesterday that test was me. What you know?
I didn't. Oh,
I didn't take mine.
yeah, we've got to talk about that too. Okay. So, if I asked you what a y-intercept was, what would you tell me? Where your graph intersects the y-axis. So, this bottom flap, where the graph intersects the y-axis. All right, this pen's got to go. I need my good pen.
What do
Here's
get
the
your
pen.
pen?
Listen, I go through so many of these pens, it's not even funny.
Pink ones?
No, just these pens in general. I love these square pens.
I
can't help it.
I love them too, but you know I don't buy them. So. Right.
Okay, so on this graph, where is your y-intercept? It's kind of like in between -5 and -6. Okay.
My,
What? Yeah.
where?
Where's your y-axis?
Oh, I mean, yeah.
Where does your picture cross it?
-5.
Okay. It actually kind of looks like it's somewhere in between -5 and -6.
You can put 5.5.
So we can do, it's at -5.5. We'll do it that way. Oh, your minimum was also at -2, -8. Yes, your vertex was at -2, -8 on your graph. Sorry, do I need to make this bigger?
It's just kind of, hard to see because of the black section.
I got you.
Miss Smith, you know how I told you I had a bad morning that one day? Okay, so let me talk about this. Yes, we did.
My sandwich.
Yo, I dead serious just cut my finger, but I'm not bleeding.
All right. You said you know what the axis of symmetry is.
Yeah, that's the thing that goes in the middle.
It's the line that cuts it in half.
Yeah.
Okay. So it's an imaginary line. Whoops. Let me move over to here. Imaginary line that cuts your graph in half. Okay. So in other words, it's the line of reflection that makes the left side match the right side. Okay. It is a line. So you cannot just tell me your axis of symmetry is 2. You have to state it as a line. So anytime you tell me the axis of symmetry, I need x equals first, because it will always be a vertical line. We're going to do that tomorrow. We're going to do that tomorrow. I just want you to be able to look at a graph and find these right now. Tomorrow I'm going to show you how to input the equations and get all the stuff from an equation if you don't have a picture. Okay, so where on my x will my graph be cut in half? -2.
-2. -8.
I think I'm actually going to grab a highlighter for that.
Oh, I mean, I'm confused, but I see what you're doing now.
Okay, so that is your axis of symmetry. Axis of symmetry. And that's x equals -2. Okay. X equals -2. So notice the x part of your vertex and your axis of symmetry should be the same. Take a look at your vertex. -2, -8. -2, -8. -2 was the x part of your vertex. And that matches your axis of symmetry. It should happen every time. Mind blown.
What's so mind blown?
Right.
They're mind blown over the fact that this -2 matches this -2.
Your vertex is real. How is that mind blowing?
I'm being
Sarcastic.
dramatic. Yes.
You.
But I love it
Okay.
because she's like me. You know, I'm like,
Oh my god.
okay. We're going to leave domain and range for last because that's what everybody seems to suck at. Okay. Roots. Zeros. I want you to add another word. Roots, zeros,
Ridiculousness.
solutions. Actually, we're going to add 2 words. Roots, zeros, solutions, or in other words, x intercepts. Okay.
Why do they gotta give us these terms?
So each one of those words mean the same thing. If I ask you, find me the roots, I want to know what are your x-intercepts. If I say, find me the zeros, I want to know where are your x-intercepts. If I said, find me the solution, find me the x-intercepts. Okay. They are going to tell you this in as many ways that they can because y'all are going to go, wait, what's that mean again?
So
Yeah.
the solution for that will be
-6 and +2.
How do you know that? Oh, you're
So you find your x-axis and find where your graph crosses it. It does that here, and it does that here. So these are your x-intercepts. So that's -6 and +2.
I'm trying to save these black people.
So the 2 lines that go through your X.
It's not always necessarily going to be 2. Sometimes you can have just 1. Sometimes you can have none. Okay, so we really don't have room to, actually, no, let's put it on here, just so you have it. Okay, so up at the top where you see quadratic functions, I want you to add in an xy here, and I want you to add in an xy here. Okay. On this first one, I want you to draw a parabola that does this And on this one, I want you to draw a parabola that does this. Okay, your graph on the left only touches that x-axis once. So there is only one x-intercept. Okay. Sometimes you'll have a parabola that won't touch it at all, which means there are 0 x-intercepts. Okay.
But then there would also be no solution.
Absolutely. And actually, later we're going to talk about technically there are solutions, they're just imaginary.
Period.
And I'm going to introduce you to the imaginary number I.
Number.
Don't they have
Yeah.
don't they have a 0 thing on here like that?
This is why I told my parents I want to go.
When you put letters in math, it's confusing.
This is why I
Really, I like to do it with 2 plus 2.
I don't
Not
know.
like X minus
I'm
3.
gonna be in class.
3A.
My favorite is, did you ever
0 plus 0.
did you ever see the kid that had this problem and it was like something like this and it said like X and 7 and it said find X and the kid went, there it is.
I'm there. I did see
I saw
that.
that too.
Oh, yeah, I saw
Those
that.
stupid math things,
Yeah.
I was dying.
That's
I mean-
crazy.
The way they worded it, he found X.
Exactly.
It should technically be worded find the solution for X, find the value of X.
So
they really worded it wrong.
So he should get 100. Period.
Period.
Hey, he broke this. He cracked the system.
Correct?
You'd have to say correct.
He cracked the system.
You said you didn't want to say correct.
All right.
He really think he cute.
We need to talk about domain and range.
He's 19.
We
Okay.
didn't even write anything.
So,
19 now.
domain. Domain. On the left-hand side, what do we know about domain?
A large number.
It's
Right.
Oh, crap. We didn't write anything. You're right. Not bad.
I was so confused. I'm like,
Sorry. I forgot to write in the definition here for solutions, roots, and zeros. So this is where the graph intersects the x-axis. There could be 2, 1, or 0 solutions.
It sounds like you're racist.
Right. Sounds like you're trying to like erase something off the desk.
it don't work.
He's making noises.
He was wanting to be racist from the beginning.
Okay. So, domain and range seems to be what everybody struggles with.
Yes.
Okay. So, domain. All values of X.
Isn't this like where one point to the other point stuck in the middle?
Okay. So, I'm going to try to make domain as simple as I can for quadratics. It changes for every different type of graph you have. So, my parabola looks like this. Okay.
It's a nice parabola.
What's happening up here?
It's going up and up and up and up.
It's going up and up and up and up and up. As it goes up, it's also going which way?
Oh, no, not that way.
It's going out this way. Okay? So, this end of my parabola is going up and to the left and never ever stopping. Okay? So, it's going to continue going up and to the left and never ever stop. Because that arrow's there. If I would continue to graph this, it's going to keep going like this
Oh.
and just go out and to the left and never stop. What's the right side doing? Going up and to the right and never stopping. So, in other words, my graph's going to continue to go to the left, and it's going to continue going to the right. Well, if I'm going to continue going to the left, what am I heading towards?
Negative.
Negative what?
100.
100.
Infinity.
Negative infinity. It is never, ever stopping. I was hoping somebody was going to do it before I walked into the bookshelf. They made me do that last semester just because they wanted to see me walk into the bookshelf.
Miss Smith, I don't think we said infinity. I think we said.
No, you said infinity. Uh-huh. Okay.
No, she goes to the right.
You just said
Yeah, go back to the
negative.
right side. You didn't do that?
Okay. So it's going in the negative direction and it's never stopping. So it's going towards negative infinity. So that means my domain is negative infinity. Okay. You make me walk into that cart. We're going to have a problem.
It's
What
kind of
card?
hard drawing an infinity.
What card?
Okay. On the other side, it's going to go to the right. And to the right.
Positive infinity.
No.
Thank you, Kathy.
Okay.
Woo!
How dare you? I think I lost. Like, I'll piss me off.
Woo!
We do.
She just threw it in your face.
I'm just.
Okay, so my graph is going to always go straight out to the left, and it's going to continue to go out to the right. So my domain is negative infinity to positive infinity.
It'll always be okay.
Always. Your quadratic, take a look at it if I put it upside down. Okay, if I put my graph upside down, what's my left-hand side going to do then? It's going left and down.
By 100, right?
This is going right and down. So either way, my quadratic graph will always go to negative infinity and positive infinity. That will never, ever change.
So it'll
Ever.
always be negative.
Huh? Because they can never find a number that numbers just keep getting smaller and smaller and bigger and bigger and bigger and bigger and bigger and bigger. It's a never-ending number line.
I thought you said it would change within the graph.
When we start to do radical equations and
Okay.
yes, when I change the different equation, the graphs change. Okay, so listen. Another way that you can write negative infinity to positive infinity is they can also write all real numbers.
But there are no fake numbers. There are also irrational numbers.
Oh my God. Shut up.
I'm just saying, like y'all should remember this. Mr. Harrison talked.
There's imaginary numbers too.
Wait, all real numbers, like no negatives?
Real numbers are negative and positive.
And then they have
Not
decimals.
Mr. Harrison.
How is that
They
hundred?
have Harrison, but Harrison helped me like.
Yeah, he does good. Yeah, because
Unreal numbers would be like 3 eyes. And we'll talk about this later. Anything you can find on a number line is a real number.
It's famous.
Miss Smith.
All right.
I said this to the teacher.
Because
Which you wouldn't what?
I like to learn the topic. She
Who's
actually.
that?
She helps me with tutoring.
She just can't teach a big quiz.
She can't.
Okay. So, on the other hand, if my domain is all of my x values, my range is then
All the way.
all values of y. Okay.
it's over for you. Jail.
Oh yeah, your mama.
Okay. So, hold on.
Kelly said it.
Okay, this stop. Okay, so range was how far to the left does it go? How far does it does it go? Your y is going to be how low does it go? How high does it go? Okay, so if you take a look at this graph, Whoop, as I throw my pen.
Don't throw stuff.
Listen, I got butterfingers. It's all right.
Killed yourself.
With a marker?
Okay.
Okay. If you take a look at this graph, how low does my graph go?
To the floor.
-8.
To -8. Okay? So that means that my range goes no lower than -8. Okay? So it goes no lower than -8. How high does it go?
Infinity.
Infinity. It's going to keep going up. Positive infinity because it's going up.
That's not going down. Fix on your-
Okay, never mind.
You used the wrong bracket.
Okay. So she just said you used the wrong bracket.
No, you use the right bracket.
I used the right bracket.
Why?
So
You have to-
listen,
Because.
-8. Okay. If it is a point on the graph, you need a square bracket. If I put it a rounded bracket, that means that my graph would look something like this. And it would have a hole there where there would be no point. You're going to talk about this in Math 3.
But I'm so confused.
Holes are
Why?
going in Math 3. This from there, you can take pre-calculus, discrete math with me, AFM.
Oh, I'm taking this.
So this tells you that there is a point there. That -8 is a point on your graph. If I would make this a rounded bracket and -8, that means that there's a hole there and not a point.
But why would that mean that? Just because?
Because the bracket. So
Welcome to math.
I can't
Welcome to
stand
smart people
it.
make yourself feel smart.
I don't know. I kind of looked at it when I was learning this and said, with the square bracket, I feel like it's contained, it's kept, so it's there. And with the round one, I can kind of throw it out, so it didn't matter.
What?
You know, because you know, like bricks and balls, you know. Don't take the balls the wrong way.
Okay. So, hold on.
You know, balls.
I want to talk about one more thing. One more thing, Teron. You got this? You ready?
Yeah.
Okay.
Am I gonna remember it?
Sure.
Oh, yeah.
Okay. Take a look if I flip my graph upside down. We said if I flip it upside down, that means it goes down into the left and it goes down into the right. And we had a maximum. I'm going to make this maximum, I don't know, 2,5. I'm just going to make it 2,5. So let me blow this up a little bit. Okay, when I write it like this, okay, I always want how low does it go to how high does it go. Well, when I flip my graph upside down, how low does it go?
Infinity.
Negative infinity, because it's going down. So this one would start actually at negative infinity. And how high does it go? 5. Okay, so depending on how your graph is facing, up or down, will depend on how your range will be. It's either going from a number and up or from a low up to a number.
So
Okay.
do we not when the
Huh?
vertex always have to have that.
Okay, another way you can write these, just like you could write all real numbers, I can write this as y is greater than or equal to -8, because it's going up. Or you could rewrite this one as y is less than or equal to 5.
Are we ever going to flip it like as a problem? Like for a problem? Or not?
I mean, we're gonna talk about transformations.
Oh,
So I should be able to give you an equation, and you should be able to tell me it's upside down, it moved to the left, it moved up,
I'm starting to remember.
and it got fat. You'll be able to tell me if it gets fat or skinny.
Now let me tell you this. I'll be having trouble remembering if it's alternate interior, alternate exterior. I don't remember that. If it flipped or not. What?
What? Oh, he's saying that if he has trouble with alternate anterior,
Oh.
he'll have trouble with this too.
Listen, I found some awesome things on IXL that I'm going to post on Canvas, so you guys can get into your IXL accounts
That's not good.
and work stuff at home.
Because I'm not gonna get it done if it's online. I'm just being honest.
He gonna play
I'm
PlayStation.
gonna be playing games. At least I'm telling the truth. It's not gonna get done online.
All right. This clues in on page, what did we say, 68?
Yeah.
68.
Yes,
Can you stop recording now?
I'm gonna show you how to glue in the next piece.
So
That
this
way
is
whoever's,
unit 3?
oh, everybody's here.
Unit 3, right?
No,